Example 1, we're doing an infinite limit here as x approaches infinity, 3x squared minus x minus 2 over 5x squared plus 4x plus 1. We haven't done limits in a while, so it's kind of a refresher course on limits. The purpose of an infinite limit in graphing is if the graph is approaching a horizontal limit. In other words, as it goes off to x going to the largest number possible, the graph itself is getting near some number. It's leveling out somewhere, or is it going up to infinity or down to negative infinity? All right, that's what we're trying to figure out here. So, the way we're going to do an infinite limit here is we're going to multiply top and bottom by 1 over the highest power in the entire fraction. Not just the highest power on top, the highest power on the bottom, but the highest power on the entire fraction. So, in this entire fraction, x squared is the highest power of x, and multiply by 1 over x squared. If this said x cubed, this is 1 over x cubed, that's 1 over x cubed. So again, whatever the highest power of x in the entire problem is, multiply top and bottom by the exact same thing using good algebra. Multiply the top of the fraction by itself and multiply the bottom by the same thing. The end result of that multiplication is this becomes 3, this becomes minus 1 over x, this becomes minus 2 over x squared. And on the bottom, 5 over x squared times x squared, 1 over x squared makes 5. 4x times 1 over x squared plus 4 over x, and 1 times 1 over x squared makes 1 over x squared. So we ugly up the fraction a little bit basically here in order to do this. And again, as x approaches either positive or negative infinity, this is the technique for a rational fraction. At this point, if I were to substitute infinity in for x, any number, no matter how big the number is, it could be 50 trillion here, any number over x as x approaches infinity equals 0. In general, limit as x is approaching infinity of any number over x is always equal to 0. Because even 50 trillion is a big number, infinity is so much bigger than 50 trillion that divide by it you get 0. You divide 50 trillion into infinity pieces, every piece is invisible. Can't be seen. So we have number over x squared, which is again just basically x squared, that's infinity squared, now still number over infinity, number over infinity, number over infinity. All four of these circle things end up equaling 0. So I end up with 3 minus 0 on top, 5 plus 0 plus 0 on the bottom, so 3/5 is the result of this limit. And again, all that tells me is as x grows in size, if I'm trying to graph this thing and I'm going x equals 50, x equals 100, x equals 1,000, x equals 10,000, whatever, the value of this function is going to be getting closer and closer to 3/5, which creates a horizontal asymptote at y equals 3/5. One of the techniques of graphing that we're going to be dealing with here in the near future is going to be identifying vertical and horizontal asymptotes. An infinite limit is the way you find a horizontal asymptote. Again, the answer to the question was this, but this is where we're leading up to. We're going to be getting to horizontal asymptotes. That's going to be one of the techniques necessary for graphing.